Hello, I'm Albert Lee doing Lab 1 for Physics 2 charge tape. So our goals of this was basically to determine what the charge sign was on tape, and then, by that deficient, efficient, or excess or deficient values, how many electrons, and then we would run that through our VPython. So some things you're going to need to know is, of course, Newton's second law. Basically, at static equilibrium, net force is going to have to equal zero. This is because force on an object, according to the law, is mass times its acceleration, and if acceleration is zero, net force is going to be zero. So we have a little free body diagram kind of explaining that with we're going to have to know that gravity is pushing down, something is going to have to keep it up to get net force at zero. So of course now you're going to have to know about gravitational force. That's pretty simple. Another mass times acceleration, except we know that the acceleration of gravity is 9.8. Then electric force is what we learned in class. It's just using Coulomb's equation right there. And yeah, that's going to be the upward force keeping it at static equilibrium. So some assumptions we're going to have to make is both tapes were charged exactly with the same charge when we create them. Then we were also given the constants for atoms per meter squared in the tape, and then also the grams per meter squared of the tape. Also, we're going to assume no air resistance and no air pressure affecting the net force. What was found? So we found that the tape was actually positive. Here's the charge that we found, and then of course, since it's positive, it's going to be deficient. So we can go into how we found that. So given we made these two tapes, we by doing this little kind of strip off the table method, then we connect it to these two poles, bring one of the tapes on the bottom, and try to make the second one float slash be affected, repel each other. And that is going to show us where the net force is zero. So our observations for the two tapes together was that they repel each other. Then when we compare it with the hand, they attract. That doesn't really tell us much because the hand is neutral. It's always going to attract. But when we bring it to a negatively charged pen, they attract each other. So, since the pen is negative, you're going to need the opposite to attract. That means the U tape is positive. So here's us doing the suspended tape part. We found that it starts to be suspended at 0.0323 meters or 32 centimeters. So here's our free body diagram. You see 2 is the gravity pulling down, and 1 is electric force pushing up, making it net neutral, net zero force. So yeah, we here's some calculations, found the mass of the tape, then multiplied that by the gravitational constant, or not the gravitational constant, just gravity, and that gives us the force of gravity. Then we put that, kind of on, say, like the left side of the equation, and then we set that equal to the Coulomb's equation. We plug in our separation distance. We know Coulomb's constant. We're just solving for Q, and there it is at the bottom. Then, of course, we know since it's positive, it's going to have a deficiency of electrons because when it's positive, that means it doesn't have enough negative charge. Um, so, just doing some dimensional analysis, we find that it's lacking 9.42 times 10 to the 10th electrons. And then some more dimensional analysis to get the ratio of atoms to electrons and whatnot. Here's our glow script, or my glow script. We have at the top left, we have the constants and slash measurables that we got. Plug that into the equation in the middle that finds the tape charge. Then at the bottom, we have what calculated the simulation. You can see the simulation at the top right there with the suspended tape being affected by the two forces. Here are our results. They just align up with what we found. This is what we've been talking about for the last few slides. Some final thoughts. What if they had swap charges, basically, is what the first one's saying. It would just be the same because the interactions just rely on whether they're the same sign or opposite signs, and if they just completely swap, then they would just, have the same exact interaction of repulsion. Why is it important that we don't touch the tape, basically? that is because our hand is a neutral object, so when we touch something that is a net positive, it's going to be sending in electrons to try and make that piece of tape also neutral. So over time, it would just make the tape neutral, no repulsion. So yeah, we might have some error with touching the tape. We might have touched the tape a little too much, made it a little more neutral. Human error is always there, and then also those values, those constant values we were given are a little iffy. But yeah, thank you.